Hi guys. All right, welcome to the next session here in track 3. This is Advanced Windows Monitoring, WMI, PowerShell, and VBscript. And if you'd please welcome Yancy Ribbens.
All right, well, thank you guys for coming. Oh, that's fine. Thank you. All right, well, I'd like to thank everybody for coming. Hopefully you'll find this session informative. My name again is Yancy Ribbens. I'm a student worker at Nagios, and it's a great place to work. Always new challenges, always learning new things. So we're going to go ahead and get started. This session is Advanced Windows Monitoring using WMI, PowerShell, and VBscript. And to talk a little bit more in detail, a broad overview of what this session will be covering is tips and techniques for writing plugins pertaining to VBscript, PowerShell, specifically how to use the return codes, give everybody a baseline of the easiest way and the quickest way to get yourself up and running with scripting. We'll also be covering how to deploy and run the external scripts using NS clients and NRSWin Win. And then we'll also be discussing WMI and how we can utilize WMI to make monitoring easy. Okay, so just real quick, why do we use external scripts? What's the benefit? Essentially, scripting makes for a highly customizable monitoring solution. So in your environment, you might have proprietary systems where plugins have not yet been developed. So external scripts make it very easy to develop those. They're easy to share. There's over 2,000 already developed plugins on Nagios Exchange. And we encourage you to upload your own if you write something new and innovative. And why use Nagios along with scripting? Well, as you'll see in this demonstration, Nagios makes it very easy to write your scripts and then send that data back to Nagios for Nagios to do the monitoring. Okay, so one of the core foundation pieces to writing scripts is understanding how the plugin return codes work. This is pulled from the developer guidelines on SourceForge. So there's 4 main service statuses. 0 indicates everything is okay, so that means the script you developed ran, everything was in bounds. If it returns a 1 or a warning, that means, obviously you've hit a warning threshold. So an example might be, you develop a script to monitor your hard drive space. And once it hits 80%, once your hard drive is 80% full, you want your script to basically exit with a 1 for warning. Along those lines, 2 is critical. So, maybe you hit 90% and you want your script to exit with a 2. And lastly is 3 are unknown. That's basically any unhandled exceptions, any low-level errors. And we'll be looking at some more examples here. All right, so this is pretty basic. Just to give you an idea of how return codes work. In the upper window here, we have a PowerShell console. And you can use the last exit code as a variable within PowerShell, which shows you what the status was to the last program or application that you ran. So I'm just doing a ping against the local host, and then I'm checking the exit code status, and it's showing a 0. And then likewise, the command DOS shell is showing, has the error level, and that's been around since the early DOS days for as long as I can remember. So you can see how fundamental and built-in error codes are to the OS, and that's what makes developing external scripts for Nagios so easy, is we basically use this as a foundation when developing our scripts. Okay, so the first example we'll take a look at is a script called Check DC. It's a VBscript for monitoring your domain controller. I selected this one just because of its utilitarian purposes. Anybody monitoring a Windows environment will likely want to know the status of their domain controller. So we'll take a look at that. Okay, so this is a script. It looks like the author was Felipe. Thank you for the contribution. So basically, this is a sort of wrapper script for something called DC dialog. Some of you may be familiar with. So essentially, on line 58, I don't know if everybody can see all right. So on line 58, we're basically setting the command we're going to run on the VBscript. So this is basically DC dialog. These are the different tests that it's going to test. It's going to test for replications, advertising, services, etc. Important pieces for the domain controller. And as we look down the script here, so basically what's happening is we're parsing the output that comes from DC dialog. So we're looking for keywords such as passed or failed. And let me actually go back up to the beginning of the script here. So at the very beginning, we're setting our int OK, int warning, int critical. Those are the return codes that we looked at previously. And so in the case where everything passed with the DC dialog command, we're going to set services equal to OK, replications equal to OK. Pretty straightforward script. Down at the bottom here, we're going to basically build up the message. This is the output that will be displayed in the Nagios display screen once the script ran. And then here's basically the key foundational piece. Once we exit, we're going to quit with the int critical if there was a warning. So basically what this script is doing is if any one of those tests failed, it will exit with an int critical. Otherwise, if they all turn out to be OK, it will just exit with int OK. And I seem to be messing up my slideshow here. Okay, so the next we're going to look at is briefly, here's just an example of running that script right in the command line. Actually, in the PowerShell terminal is what we're using to run it. So I'm testing the domain controller. Everything came back as OK in the first example. I'm using the last exit code to show the last exit code was OK. That's going to be transmitted back to Nagios. And then in the bottom, I basically stop some of the vital services for this domain controller, something not recommended in a production environment. But as you can see, everything went to critical. The last exit code is 2, which indicates critical. Okay, sorry about that. So, we use the same ideas with PowerShell scripts as well. We're going to look at an example, check Windows app installs. This is just a basic PowerShell script And what it does is it checks for newly installed programs on a Windows machine. So anything running PowerShell would be able to run this script. PowerShell, as you know, is included in the later versions of Windows, R2 and beyond. But you can actually add in PowerShell to 2003 or XP as a separate add-on. So real quick, we're just going to dissect this script. Essentially, we're querying the registry. We're asking for what currently installed programs are on this system. In the case of a 64 or 32-bit system, they may be in different locations. So we're testing for which system type it is. We're building that array. And then down at the bottom here is basically, sorry, just give me 1 second. Okay, so here's basically what makes this script useful. When it runs, it builds that program list, and the next time it runs, it builds another program list cache. And then we're using the PowerShell compare objects. So PowerShell makes it really easy to just compare the two objects and see what the difference is between the two. Something that hopefully you guys will find useful. And then down below, we're doing the validation to say, okay, if nothing changed, we're just going to print the count of the program files. Otherwise, if it did change, okay, yeah, so if there's new program files, it's going to show the program files and then show what the delta or the difference is. And this is an important piece. The \n indicates a new line. So when you do that \n, it basically pipes the additional output to the long output of Nagios, which you can see in the details. And we'll take a quick look at how that looks. Otherwise, we're just going to show the program files count. So again, here's how it would look from the Nagios XI interface. So you can see in this particular instance, we've counted 3 program files. There's not been any added or removed since the last time we checked.
So how would you manage that? If it goes warning, then somebody have to go edit the configuration.
Well, basically, what happens in this instance is if it goes warning, this will show up as a warning in the Nagios interface. And then the next time it runs, it'll go back to an OK status. Right, it's just going to warn the one time that there has been a change. And so what I was talking about previously, here's basically the more detailed view. So if you click on that service, it's actually listing on this particular system what applications are installed. So this is everything that came after the new line character. So you can see right host, total, new line, everything after the new line will appear here. And it's preferred that if you have a lot of data to dump, this is where it would go. I believe you can write up to 4K in Nagios XI. There's 250 character count max in just the regular output section. Okay, so we have some foundational pieces for how to develop these scripts. We're now going to take a look at what are the best ways to run them. How do we deploy them? How do we implement them? One of the newly developed tools that we've been working on is something called NRDS. I've been working on the NRSWin Agent. Here's a sample configuration, and I actually have a clip of how this would look in a real environment. Okay, so here's the Nagios XI web interface. And we're going to go to the NRDS config manager, and we're going to select the install option. So directly from the Windows host, we're going to open the NRSWin Agent and run the installer. When you run the installer, you need to provide the IP address of your Nagios machine, as well as a valid token, so that we can validate the information coming from the client is legitimate. And then you can also specify a configuration name and a host name. And this allows you to be able to manage all of the plugins from a central location. And so basically in this example, I'm selecting the token. I'm going to put that in my NRSWin installer. And if you go back to the NRDS config manager, we currently have a config for Windows 64 machines. And then during the install process, there's a unique name that's given. So this is what's going to report back to Nagios. You can actually specify multiple unique names when installing this agent, so you could have multiple versions of NRSWin, or as we like to call it, NRSWin running. Okay, so the installer just ran. Basically, NRDS is a passive agent. So it runs its checks and sends the results back on a regular interval as defined by the task scheduler. So as you can see, there's the host name. And next, I'm going into the NRSWin configuration file. So the config.ini is where we can put all of our plugins. So as you can see, on a blank install, only the settings exist. And what happens is the NRSWin agent, every time it runs its checks, it will check to see if there's anything new for it to download, i.e. a new config. So basically, I'm just manually invoking the task, so we don't have to wait 7 minutes or whatever the interval was. So as you can see, after the NRSWin agent ran, it downloaded all the configs that we had defined in our configuration on the Nagios XI side. And then in the log file, it shows you all of the commands that it's actually running. So when it runs each of these, it replaces plugin directory with what the actual plugin directory is. And you can see the actual commands that are being parsed, and then here's the data being sent back to Nagios. So the first time it runs, they'll basically appear in the unconfigured objects. And this is showing, once you add them from the unconfigured objects, they'll exist in your regular host and service views. So there's the service statuses. And we can probably fast forward a little bit here. Oops, not too far though. Okay, so there are all of our checks returned. You can see the check DC is one that we talked about, as well as the installed applications. So NRDS makes it very easy to manage all of your configurations centrally. Scott Wilkerson actually will be talking more in depth about this new tool. Sorry guys, I'm not sure why the slideshow is not letting me progress here. Okay, looks like I have it running. And just real quick, here's an example of, we're adding a new configuration, or a new plugin rather. We're adding a plugin that's a PowerShell script that will test the replication of the domain controller. And, well, it's probably kind of hard for you guys to see, so I'll pull up the slide here in a second. So essentially, here's the new service name that's being defined, and I'm going to paste in the PowerShell script. PowerShell scripts are a little odd when you run them. When you define them in either NSClient or NRSWin, basically the contents of the PowerShell script is echoed across, and it's executed by PowerShell.exe. So essentially, every time you make a modification to the config file, the config's incremented. In the background, I'm running something called SMS trace, which is kind of like running a running tail in a Linux environment. It lets you monitor a log file. So basically, I'm monitoring the NRDS log file as these checks are being run. Okay, and so here's the new check that comes into unconfigured objects. From here, we're going to pass this in, and it will be viewable in our services and host view. Okay, so as I was talking about, here's how you would define an external script. You'd basically, the plugins directory is interpreted, and it runs, for example, a PowerShell script, and it echoes it across to PowerShell.exe. Likewise, here's an example of a VBscript, which we're calling with cscript. You want to do no logo, otherwise you'll get the Windows logo in the output of the script. And I don't know who she is, but I like her taste in software, so I thought I'd put this on here. Okay, so next we're going to talk real quick about NSClient++. And if you're running external scripts, here's the basic modules you'll want. The nrplistener.dll, check external scripts.dll. You'll want to use file. You can also use registry instead of a config file for defining NSClient settings. For this demonstration, I'm just using the config file. Important external script. You guys might be familiar with this aspect, but allow arguments needs to be turned on if you want to send arguments. Allow nasty meta characters if you want to use meta characters when calling your scripts. And here again is the definition of our scripts that we're running. So we have the check domain controller. We're checking for Windows updates. We're checking the installed applications. Very similar in syntax to what we looked at with NRSWin. So if you're running a Linux environment and you have a number of Windows hosts, how do you install NSClient? How do you monitor those configs and update them? What we're looking at here is just a quick demonstration of a tool called npush. And so what's happening is npush is actually authenticating with the Windows host, running the agent installer, downloading any scripts, and then starting the service. So this is happening all in one step. Tomorrow's presentation, I'll be going more into how to configure this tool. And as you can see, NSClient++ is now in the program files directory. So once we've done that all from Nagios, it's pretty straightforward to set up the configuration, especially with some of these wizards. So like, for example, the NRPE wizard. We're going to select the Windows hosts as our operating system. So that's the IP address of the machine that was just installed. Just had NSClient++ installed. There's some default checks that came configured. So here's an INI file that was pushed to this machine. So now all I'm going to do is basically take the check DC, check updates. I'm going to plug them into my remote NRPE commands. And it's pretty straightforward from there. Looks like I'm actually having some issues with the mouse on, on this demonstration. Oops. And we're just putting in the display name, what the service will show up as in Nagios. Does anybody have any questions at this point? Okay, so NRPE is finishing the configuration. So like, the main difference between NRSWin and this tool we're looking at now is NSClient is an active check. So all the scheduling, all the checking is being initiated from the Nagios end. NRSWin was basically running on a schedule, sending the checks back. So there's some obvious advantages to sending passive checks back. Namely, you don't have to worry about, there's circumstances where perhaps the Nagios machine can't contact the Windows client. So a passive agent allows you to get around that by just initiating the connection from the client side. Okay, so let me fast forward here. So basically, we're just waiting for the pending checks to come back from the NSClient agent. NRPE, rather. As you can see, when I did this deployment, I noticed there was a critical. So I'm looking in the left window, I'm looking at the DC dialog to try and figure out what that critical message is. Check install apps came back okay, so you can see there's 3 apps installed. Okay, so next we're going to take a look at Windows WMI, how we can monitor WMI clients from our Nagios installation. In my opinion, Microsoft did a fairly good job of adapting the WBEM standard. I find it a lot more straightforward and useful than, say, SNMP, trying to look up OID numbers. WMI is very powerful because you can use WQL statements, which are basically SQL-like syntax. So you have your select, star, from, Makes for very powerful queries. And within WMI, the default class is CIM v2, which is most of the data we'll be pulling uses the CIM v2 class. Some other really cool things about WMI is, well, like for example, if you install Hyper-V, it adds on the virtualization class, which you can then use to query your hypervisor. And another really useful class, like the Microsoft Active Directory, for example, you can guess what that does. And just briefly, so WBEM also exists in the Linux environment as well. There's OpenPegasus, which it's a little bit different implementation, but based on the same idea, and just really cool technology. Okay, so we're going to look basically at, we're going to follow the logic. How do we pull this WMI information from our Linux machine? So basically on the top is Nagios, which basically just displays and schedules the checks. What it does is it calls check. Well, actually, it'd probably make more sense to look at it this way. So we have our Windows WMI provider. WMIC is the tool on the Linux side that actually does the queries. So we'll look at how that compares with just running the queries directly from within PowerShell. So you can kind of use that as a tool to figure out what information you want to pull and how to make the definition happen. So then check WMI plus takes that data from WMIC and formats it into usable check data by Nagios. And then on top, Nagios basically grabs that information and does the rest. Okay, so here's a really basic select statement. So we're selecting star from Win32 perf raw data. So this is giving us a bunch of useful information on the physical disk. Average disk bytes per second, average bytes per read. And then if you look on the Linux host, which is running Nagios, we can do the exact same query. So we have select star from Win32 perf raw data. The data comes back a little hard to read, and that's part of where check WMI plus comes in, is it formats that for us. So basically we have our header information here. So our header corresponds to the numerical values down here. So again, here's the next layer of abstraction up. Now we're looking at the check WMI plus layer. So we're running the check against the same machine. Now instead of that bulky select statement, we have some predefined statements, namely the check IO physical. And so you can see when this comes back, this is a little bit more human readable, and this might look a little familiar. This is, so we have overall status okay, some more detail about the check we just ran. It's defaulting to the C drive, it's the hard drive. A really good place to find query information is on the WMIC check WMI plus website. So we have a lot of really cool pre-baked ones. So we have, for example, check CPU, check drive size, check event log. A bunch of these are very useful. And you might wonder, well, what do these definitions look like? So basically, here's the check WMI plus INI file, and we actually have everything listed here. So when we're using that abstraction, let me go look at the one we were just using as an example. So here we have the check IO physical, which might look familiar. That was the check command we were running on the Linux agent side. So that's the argument. Here's the select statement that's being run. Some other useful ones. Here's a really cool one. This is actually listing the software on a 2008 machine without the use of an agent. So that's really the power of WMI, is that you can remotely query this information without having to deploy any type of agent. We'll look briefly at what the best way to configure that is. And also, for those of you that don't find the check information you need, there's some really good write-ups on how to create a custom INI file, creating an INI check based on the WMI perf data. Okay, and then the last layer of abstraction on top is basically our definition within Nagios. So this is from within the Nagios Core Config Manager. If you're running core, you would define these in your services and hosts config files. So as you can see here, we're using check IO physical, the username and password in this sample instance. In Nagios XI, we actually have a lot of really useful ones already bundled in. So once you run the agent, you don't necessarily need to do any custom configuration, but you can obviously if you so need to. And so here's an example of the service status. So here's our check IO physical. Everything's okay based on the thresholds that were set within the INI file. Here's the service status details. So configuring WMI on the Linux side is made really easy, especially if you're using XI. We have an installer script which basically installs the WMIC agent, check WMI plus as well. And I'm getting the 10-minute warning here. So, and then basically on the Windows side, we're going to look briefly at if you wanted to configure WMI. By default, any administrator level account will have access to the namespaces that are used by WMI. So you could just out of the box, as long as your firewall rules are set, just use an administrator level account. That might not be the best way to go for security. So what you can do is just create a limited admin account and then give it access to the specific namespaces. So in this instruction, we're basically showing to make sure the WMI agent is running on the Windows host, how to create user accounts, adding permissions. So WMI uses Microsoft's distributed COM object to facilitate the communication. So that also needs to have permissions given on and here's an example of how to do it on a user basis. And then we're giving access to the specific WMI namespaces. So this can be found on the assets site on Nagios XI. And firewall settings for 2008 and 2003. Okay. And just one really quick thing. The best way to test WMI connectivity is from one Windows host to another. There's something called WBEM test, which I frequently use if I'm trying to troubleshoot a WMI issue. Here we're just putting in the namespace on the remote machine we're connecting to along with the valid credentials. So that's it for the presentation. I guess that brings us to the Q&A portion of the talk. Hopefully I didn't bore you guys too much.
So, Yancy, just so people understand, I mean, one of the benefits of NRSWin, or as you mentioned, we call it internally NRSWin. I'm going to get a T-shirt made that this says NRSWin with Nagios or something like that. But NRSWin has the benefit of it's a passive agent that you can continue to manage the configuration and push down new plugins to the Windows box from your Nagios server. Like, you're not having to remote into your Windows box and update the ini files like you do with NSClient++.
Right, exactly. So it makes central management easy. So if you have 500 machines and you're wanting all of the same configurations to be spread across those 500 machines, or even some of those machines to use a different configuration, you can do that all by configuring different names from within the passive agent.
So with a passive agent, does Nagios alert when it hasn't received an alert from a passive agent over a period of time, or?
Not by default, but there is something called freshness checking, which can be configured in the core config manager. So you can configure bounds so that yes, if communication from the client is not received, do some kind of warning or critical status. Yep.
Okay, because NSClient's more of an active one, right? Like you would.
Yes, exactly. So
Okay.
NSClient is the active agent. So basically, you can do all of your intervals and everything is defined by Nagios. So it's initiating the communication. There's some situations where a passive agent is better versus an active agent, but
Okay.
yep.
So we've seen at least 3 drastically different approaches to monitoring Windows. Can you summarize the strengths and weaknesses, or where you would recommend each approach? Should we use all 3, or should we be moving towards NRDS? Or
Well, I really like the NRDS aspect, simply because, again, like, you can have disparate hosts, and they can basically initiate the communication back to XI. So that's something else that is in the works, that we're working on a tool called the Reflector, which is another very cool project. But more to your point, active checks are really customizable and beneficial, but I would say it just depends on what your circumstance is. So, I mean, yeah. Hopefully that answers your question. I don't. So, yeah.
If you want to use WMI queries or run WMI checks, you can still use that with the passive agent, like NSClient++, because that can be configured in passive mode as well, or
Correct.
NRDS. So you can still use PowerShell scripts, query
Correct.
WMI, whether you use active checks or passive checks. So.
Yep, that's a very good point. A lot of the scripts on Exchange use WMI. So you can actually write your VB or PowerShell script to do the WMI query, and then whether you're running them with NRDS or NSClient, send that data back as well, instead of just using the agent list solutions that we talked about here.
Just to kind of tag along with that too, just from discussions I've had with people in their environments. You know, some of it depends on environment size. People might already have the WMI service running on all of their machines. And so for some people, that's preferable. If it's already there, might as well use it. But I also do know the check WMI is a little more CPU intensive than, you know, for example, a passive agent is going to give you, you know, no overhead pretty much at all on the Nagios side of things. It's only going to be listening for checks. And so, you know, if you have to monitor, you know, 10,000 Windows machines, you know, the passive agent might be a way to go because it's not going to bog down the actual Nagios server. Whereas, you know, doing, say, 10,000 servers with, you know, WMI, it's going to take a whole lot of horsepower, you know, because it's actively scheduling it, and the plugin itself is going to use more CPU. So it, you know, it depends on, you know, what you already got in your environment and the size of your implementation, at least from conversations I've had with people.
Yeah, thanks, Mike. That's a really good point. So you're saying you do have performance issues running the check WMI plus agent?
So what we do is we use that mod yearly, so we just push off all our, we have about 10,000 Windows checks.
Okay.
We use check WMI plus 4, and we just push those all off to our work group. You have to have a lot of resources for overtime. So it's happy to set up a couple groups and agents and all that.
Right.
I've had a similar experience with our setup where the convenience of WMI means it's worth throwing resources at it from the Nagios end because it is one of the heavier plugins. But yeah, we have the same success where we divide between using check WMI and using the agent is for the complexity of checks. WMI is really great for topical stuff if you're just polling counters like disk levels or whatnot. Where we're actually using NS Client++. We're using that for text log scanning. We have a lot of applications that output text logs, and there isn't really an elegant way to do it unless you're there local with an agent. So that's where we draw the line between the two. So we are actually doing a mix of both WMI and local agents on our machines, and it works out relatively smoothly.
Are you using the check log then to parse the logs on the Windows side?
Right,
or?
we're using check log files from Console Labs.
Okay, yep, sure. It's a great plugin. All right, so that is, that's it. I'm getting a roundup call here. So thank you, everybody, for attending, and hope you find the rest of the conference useful. Thanks.